Hello, welcome to the tutorial on Descriptive Statistics of the Dataset Part 2. By the end of this tutorial, you will be able to calculate descriptive statistics for the individual variables in the dataset. Use Numpy library for descriptive statistics. In the previous tutorial, we explored the entire dataset and all the variables in it together. But if we wish to find out the data of a single variable or find descriptive statistics for it, how can we do that? For example, let's find the mean value for the selling price. For this, the code will be a bit different. Firstly, we write the data file name and then in the brackets, the name of the whole variable followed by dot and mean and then again the brackets. So the code will be raw housing data sale price dot mean brackets. We get the mean value after the execution. Similarly, we can obtain the minimum and maximum values. Similarly, we can obtain the standard deviation and the percentiles or quartiles using the different functions of Python. The code for percentile is a bit different, where you have to mention the percentile that you want to calculate. Rest everything remains similar to the previous code. Up next, we can find out the unique values for a variable using the unique function. We generally use this function for a string variable for finding out the unique values that exist for that variable in the dataset. Getting confused? Don't worry. All of this would become clear to you in a minute. Let's find out the unique values for the variable condition of the house. We write the code raw housing data condition of the house dot unique and press Ctrl plus enter, and we get unique values of the condition of the house variable, which are fair, excellent, good, bad, okay, which means that certain houses in the dataset are in great condition, some are in average condition, and some in bad condition. So now do you know what do we mean by finding unique values of a variable in a data? That wasn't that difficult, was it? So far, we have used inbuilt Python functions to calculate descriptive statistics. Now, we will understand how descriptive statistics can be found using Numpy library. In the previous tutorial, we had learned to install Numpy library. It is an essential library for mathematical calculations and contains several mathematical functions. However, Python also has some inbuilt mathematical functions which we can use. And for those calculations, we don't need to use Numpy library as such. But later in the training, when we have to perform a few advanced mathematical calculations, we would be using Numpy library, and hence it would be useful to learn how to use the Numpy library and the functions in it. We just learned that we can calculate standard deviation for a variable using inbuilt Python functions like this. Now, let's do the same thing using Numpy library. Let's first import the Numpy library and assign a name np to it so that we do not have to use the entire name of the library when we are calling its functions. Type import numpy as np and press Ctrl and enter, and your library is imported. Next, let's calculate the standard deviation for the same variable but using the standard deviation function of Numpy library this time. For this, we type the code np.std raw housing data sale price, which is of the same structure as library name dot function name and in brackets input arguments. We are only replacing the variables whose standard deviation we want to calculate, that is raw housing data sale price being the input argument for the function. We had calculated the standard deviation using both the inbuilt Python function and the Numpy library. One interesting thing that you will notice is that there will be a bit of difference in both the calculations. So let's find out. We see there is a difference of 8.50 in the results obtained by both the methods, and this is because the formula used for calculating standard deviation is a bit different in both the methods. In the first method, the formula is s equal to under root sigma x minus x bar whole square divided by n minus 1, where s is equal to standard deviation, x refers to each value in the dataset, x bar is mean of all the values in the dataset, and n is the number of values in the dataset. And in the latter, using Numpy library, the formula is sigma equal to under root sigma x minus x bar whole square divided by n. As you may see in the first formula, the denominator is n minus 1, while in later it is n, which results in a lower value. We can fix this by specifying the degree of freedom as 1 as input argument in the code for calculating standard deviation using Numpy library, as shown here. Now we will get the same result. We will not get into the discussion of what degree of freedom is at this point. For now, it is sufficient for you to know that the denominator in standard deviation formula is n minus degree of freedom, where n is the number of observations. As we can see, higher the degree of freedom, lower the denominator, and hence higher the standard deviation. As we mentioned earlier, other than basic descriptive statistics, there are several mathematical functions in the Numpy library. Let's find out what all functions are there in Numpy library by writing the code dir in brackets np. Now press Ctrl plus Enter. We will get the list of all the functions. Scroll down the list and you may be able to guess what some of these functions are just by looking at their names. We'll learn more about the Numpy library and the relevant functions in it at an appropriate place later in the training. So that's it in this tutorial. In the next tutorial, we will understand how we can visualize data using graphs.